Okay, rates, ratios, and how do we find the best buy? Something that's really on our minds when we go shopping, especially when we have a choice, which we like. Ratios are, you'd think you've got this little colon in there. It's used to compare quantities of the same units, right? So you have a ratio of, we would say a ratio of A, some things, to B, something, which is measured in the same unit. Ratios in simplest form use whole numbers that have no common factor, so they're simplifying. Unitary method is really useful if you're asked to find the best buy, and you have things with different amounts and different costs, and they're in different quantities. It can be confusing. So finding the value of one part can really help us with both ratios and rates. Once the value of one part is found, then you can, and I'll show you when you're going to do this, find the value of several parts. There's a couple scenarios there. And a rate is different. A rate is where you're going to have the word per, because you're dealing with different units. For example, you have a rate of speed of 50 kilometers per hour, or it's written that way. So that per can be written as a slash, and that's when you know you have a rate. You got two different units, kilometers and hours in this case. Both ratios and rates can be used to determine if something is value for money. So let's do the simple things first. We're going to simplify these ratios. So we're not talking per, these are same units. So all we're going to do is, similar to what we would do with fractions, we need a common factor, find the highest common factor, and in this weird number, I think it's just 2. Yeah, it looks like if I divide that by 2, I get 19. If I get that by 2, now I could start by dividing by 2, and if I ended up with, say, 1812, then I know I could keep going. But at this point, it's not, and I'm done. That is the simplest form. The highest common factor between these two numbers is 2, so we divide by both of them. Now, when you've got this, remember we're looking for here a ratio, a comparison of two things. We want to find, first of all, we want to be comparing the same type of units. We got to be speaking the same language. So we're going to do what we love to do is we're going to convert these 5 over 2 to, okay, now we have improper fractions, and now we're going to do what we love doing, and we're going to find equivalent fractions that have the same denominator, and this is the best part. So 3 and 2, I think the lowest common denom, the first multiple combined that we come to is going to be 6. So 2 times 3 is 6, so 5 times 3 is 15, and in this case 3 times 2 is 6, so 4 times 2 is 8. So what we're trying to do is figure out, now that we've got the same units, we've got 15 sixths to 8 sixths. So it could be, 15 bananas to 8 bananas, or 15 crocodiles to 8. We don't care. Because they now have the same denominator, we can just ignore that because we're dealing with the same animals. Then we've got our ratio of 15 to 8. Now for this last one, I just want whole numbers. So if I multiply both of them, what would it take? 2 decimal rolls. So by 100, I've got an equivalent. So I found an equivalent that is real whole numbers, 20 to 14. And then they both have a factor, not quite of 7, we're so close. We divide them both by 2, and that gives us 10 to 7, and that is as simplified as we can get. Now, this one. So this is where we want to look at the unitary method. So we've got a total of $300, and it is to be divided in a ratio of one person gets 2 lots, and the other person gets 3 lots. Maybe somebody worked the extra hour, I don't know. So what we want to do is find out how many lots there are, how many portions are there. Somebody gets 2, somebody gets 3. So 2 plus 3 means there's 5 portions or parts. So all we're going to do, and that equals $300. So all we're going to do is one part is going to be a fifth of 300. So we divide by 5, or we take, either way, it's the same thing. It's going to end up being 300 divided by 5. And so 60 equals 1 part. We're only asked to read the question, Mr. Barrison, find the value of the larger portion, which is 3. So 60 times 3, not a very clear way to lay that out, is going to give us 180, therefore, equals 3 parts. Rates in their simplest forms. Okay, every, per, slashy slash. have 120 kilometers per every 3 hours. So what we're going to end up wanting is, what is it for every 1 hour? So if we took 120 kilometers and divided it by 3, we would get 40 kilometers per 1 hour. And that's how that would be written. Over here we have 5,000 revolutions in 2.5 minutes. So we want to find a way to get to 1 minute. And the easiest way to do that is to get this to a whole number. So if I take both of these and multiply by 2, 2.5 times 2.5 is 5. And 5,000 times 2 is 10,000. So we get 10,000 revs per in every 5 minutes. And to get how many we get in 1 minute, therefore, we get 2,000 revs per, there's our little per sign, 1 minute per minute. Which is the better value? 5 kilos of potatoes for 380 or 3 kilos of potatoes for 220. Now, this is something really important, especially if you're not in a major supermarket. If you look at the tags really closely in a major supermarket, they're going to tell you what that rate is. So how much it's going to cost you per kilo. Sometimes they say per 100 grams, and you have to work that out. Just multiply it by 10. You'd be surprised how much some things are per kilo. But if you don't have that, if you're in the market somewhere and you're trying to compare 2 different stalls at Rusty's, then you're going to have to go through this. So I've got 5 kilos and 3 kilos at different prices. So I want to know how much it is per kilo. So it's pretty simple. You've probably figured it out. I want to take 380 and divide it on my calculator by 5, because it's $3.80 for 5 kilos. And that's going to show me $0.76 per kilogram. That's what that one costs. And the 3 kilo bag, that's $2.20 divided by 3 is going to give us a dollar value of 0.73 cents per kilogram. So now we know the price per kilogram. Which one is the better one? Obviously, the 3 kilo bag is going to be the better value. You would write there for the 3 kilo that is the better value, because each kilo is only 75 cents. Not a huge difference, but every penny counts. Pennies were a little copper-colored coin. Okay, now for this one, look, we're going to do the same thing, and we're going to look at milliliters. We could go down and we could find 1 milliliter and then multiply it by 100, because that's probably how we're looking for the cost of 100 mils. And you saw that grocery tag where things will go down to the 100 mils. Very rarely will you see by millimeter, unless you're buying something really, really expensive. A milliliter, rather. So if I have 400 mils of shampoo A, which is similar quality to shampoo B, but they're different costs. 400 mils for $3.20, 320 mils for $285. So pretty simple, $3.20 divided by 4. I could divide by 400 and get 1 mil, but I just want to get to the 100 mils. So 320 divided by 4, that gives us per 100 mils, just so we don't get that wrong. And we're going to do the same thing over here with $2.85. And instead of, we had 4 hundredths, here we have 3.2 hundredths, don't we? 3 wholes, 0.2 hundredths. And that's going to give us a cost of 0.89 cents per 100 mils. So that tells us then that the first shampoo A, is the better